So very good afternoon to everyone present. I am Neeraj Rastogi and working at Physical Research Laboratory, Ahmedabad. And I would request any PhD aspirant, if you are looking for doing PhD, please go to the PRL website where we do research from means in a very large domain from interior of the earth to end of the universe. Multiple things are covered there. So you can go to the PRL website and see what kind of research we do. And if you are interested, you can come to do PhD here. Okay, and before I start, I wish to thank the organizer of this workshop, Aerosol Measurement and Retrieval Impacts, for giving me this opportunity to share whatever little bit I know about this topic. So as you can see the topic, why one should study the chemistry of atmospheric aerosols. So the way we will go, first we will talk about what are atmospheric aerosol, and then with time we'll go that why the chemistry of aerosol is important. So let us first start with aerosols. So you might have already heard, but in the order of completeness, let me also tell you again. Aerosols are liquid or solid particles suspended in the air. Now, if we talk about the major sources can be natural, like sea salts. Sea salt means many of you, if you are living at the close to coastal region, if you go towards the sea, you see that sometimes you can feel the dust, the salt on your body. So actually what happens that whenever this wave overturns, it traps the air. And when that air bursts, this sea spray, whatever salt dissolved in it, and that is how it is called sea salt or sea spray. Then you have windborne metal dust. You might have seen there many places there is strong winds, dust comes in the atmosphere. Then we have volcanic eruption. It is not a continuous source. It happens once in a while, but whenever it is happening, it injects huge amount of aerosol in the atmosphere. Then you have biogenic sources like trees, pollen, spores, or dry tree leaf, plant debris and all. They are coming in the atmosphere. They also release VOCs, which convert into aerosol, which we'll be talking about a little later. And then there can be forest fire. Again, this is not a continuous source because once in a while it happens, but whenever it is happening, it injects a huge amount of aerosol in the atmosphere. And then you have multiple man-made sources like industrial emission. Many of you would have seen the smoke coming from the industry. So depending upon what kind of industry is, it emits a variety of pollutants in the atmosphere. Then this is seen to everyone, vehicular emissions. Any city, anywhere you go, we have full of traffic everywhere, and you can see the pollution coming out of vehicles. That is vehicular emissions. This biomass burning, this is man-made biomass burning. And every year, this October, November, you hear this, there is a large paddy residue burning in Haryana, Punjab, and then thick smoke come all over the industrial plain and all. So that is biomass burning. And then you have a thermal power plant. So we need power, and for power, still major supply is through the thermal power plant, which uses coal. So there is a emission from thermal power plant. Then you also have this emission from cow dung cake burning, which is used as a fuel for cooking, which is reduced quite a bit now because of this Ujjwala Yojana and all, but still it is not removed completely. This is another source. So anyway, from whatever sources, things are coming in the atmosphere, and if they are solid or liquid particles, they are aerosols. Their size ranges from a few nanometer to several micrometer. We'll be talking a little more in details about the size in next slide. Then these sources emit particles, primary particles, as well as precursor of secondary particles. What is primary particle? So if these or any of these source, if it is emitting solid or liquid particle, that is primary particle. But if these are emitting any gases and those gases are converting into solid or liquid particles, then it is called secondary particle. If we talk about the lifetime of aerosol in the atmosphere, especially in the lower troposphere, it is just about a week. In a week, by some mechanism, it comes out of the atmosphere. But it is not always a week, means it changes with the size and altitude. Very big size particle remove very fast, very small particle also remove fast, fine size remain for longer time. And altitude wise also, if somehow you can reach at stratosphere level, then aerosol can stay there for years. But within lower troposphere, we can talk about it is just a week. Okay, Now let us talk about the sizes. So before go to specifically in aerosol, let us see what we have in the atmosphere. Now see the scale. It is ranging from 10 to the power minus 10 to 10 to the power minus 1 meter. This is 9 orders of magnitude. What does that mean? We'll talking in a minute. So actual size is from 100 picometer to 10 centimeter. This is what we are talking about. And this is all present in the atmosphere. In what form? Initially, if you have gases like sulfur dioxide, NOx, or ammonia, or VOCs, volatile organic compounds, these are the gases. Then these gases can form particles, as I was telling about the secondary particles in the previous slide. They can form particles like SOA, secondary organic aerosol, SIE, secondary inorganic aerosol. Then they can form particles, they can coagulate, they can coalesce, they can form cloud, fog, they can convert into rain or snow or droplets or hails and come back to the surface. So in a way, one molecule which was at this size may come back as 10 centimeter of big particle from the atmosphere. That is possible in the atmosphere. Now, if you want to visualize, actually, when I say 9 orders of magnitude, what does that mean? So if we take 100 picometer as the lowest size, as an ant, a small ant, cheetah, and then the biggest size we are talking about, it is moon. It is 3,500 kilometer. So in principle, an ant can become a moon in the atmosphere by different process. And many of them we will be discussing in the coming slides. Now, again, if you see, there is some kind of color coding. So if you see this all red, they are actually aerosols. Less than means lower side, this is gases, and higher side, this is rain, snow, droplets, or hails. And when I say then these particles from 1 nanometer to 100, 1 nanometer to 100 micrometer, this is the range of aerosol size. So again, this if you see as an analogy, it is coin of 3.5 centimeter, and this is 3.5 kilometer. This is a crater in Rajasthan, which is called Ramgarh crater. So a coin to a crater. This is the kind of aerosol size present in the atmosphere. Now, many of you would have heard word TSP. TSP is total suspended particulate, or SPM is suspended particulate matter. So if we are talking about all the size range from 1 nanometer to 100 micron, then it is called TSP or SPM. But if you are talking only about the particles which are smaller than 10, then you call it PM10. If you talk about particles smaller than 2.5 micron, then it is called PM2.5. If it is less than 1 micron, you call it PM1, and so on like that. It is PM.1, which is less than 100 nanometer or 0.1 micron in size. Remember, when we say PM10, PM2.5, PM1, and 0.1 are the subset of PM10. Same way for PM2.5, this and this are subset. For PM1, this is the subset. And TSP is everything together. So here, if you see carefully, size of aerosol provide a broad idea about their chemical composition. So for example, now if you are collecting aerosol just between 10 to 100 micron, then you are expected to collecting this kind of aerosols. If you are collecting just a particle less than 100 nanometer, so you are collecting these kind of particles. So you will be getting this kind of composition. If you are collecting PM10, then you can collect all these together, PM2.5, then these together, and so on. So the question comes, okay, if these are aerosols are there in the atmosphere, let them be there. Why we are worrying about? So we are worrying because they affect us in a variety of ways, which you probably would have heard by the previous speaker. You will again hear from next speaker, but I'll be specifically talking about everything with the keeping aerosol chemistry perspective in mind. So we will talking about the role of chemistry in that. Okay. So when we say chemistry, so what are the major chemical species present in the atmosphere? So I'm talking about all the species, that means gas and aerosols. And I have put like this. So aerosols I have put like bold. You will understand why. So in the atmosphere, we can have variety of carbon containing compound with oxidation state varying from -4 to +4. For example, methane, NMHCs means non-methane hydrocarbons. BVOCs means biogenic volatile organic carbon. AVOC means anthropogenic volatile organic carbon. Then PC means black carbon, POA means primary organic aerosol, SOA means secondary organic aerosol, VRC means brown carbon, and then CO, CO2. Now you probably understand that this bold and this bold. So whatever things I have put in bold, they are aerosol and others are gaseous species. Then this, when we talk about these aerosols, especially POA, SOA, there can be thousands of organic species like any other component. In your high school and 12th, you would have heard this aliphatic compound, aromatic compound. Within aromatic, you would have heard polycyclic aromatic, that means PHS compound. Then dicarboxylic acid, ketone, aldehyde, ester, etc., etc. And all kind of aerosols are present in the atmosphere. Together, we are calling it primary organic or secondary organic. But if you go in speciation, there can be wide variety of compounds. Then you have nitrogen containing compounds with the oxidation states varying from -3 to +5. Examples, say ammonia, then nitrogen gas, then nitrous oxide gas, NO, HNO2, NO2, nitric acid, and then HNO3, nitrate and organic nitrogen. These are again aerosols, and the very low concentration of nitrogen pentoxide and nitrate radical. Then you can have sulfur containing compounds with the oxidation state varying from -2 to +6. Examples, hydrogen sulfide, dimethyl sulfide, carbon disulfide, OCS, SO2, sulfate, and organic sulfur. So, as I told you earlier also, whenever we are talking, I am putting it bold means they are aerosols. Then you can have dimethyl disulfide or dimethyl sulfoxide and all. Then you have halogen containing compounds. So this is CFC means chlorofluorocarbons, SA means hydrochlorofluorocarbons, hydrofluorocarbons, halocarbons, etc. And they are all gases. As you see, I have not made them bold. Then you have ozone in the atmosphere. At stratosphere level, if you see, it is about 10 ppm concentration, which is about the total 90% of the total ozone present in the Earth system. At tropospheric level, it can vary from 20 to 80 ppb, which is about 10 to 15% of the total ozone. And probably you are aware that this ozone is like an umbrella for Earth, which is shielding us from harmful UV rays coming from the sun. Then you have mineral dust. We talked about the sources of aerosol and mineral dust. Now, in terms of chemical species, if we say mineral dust means it can have calcium, magnesium, sodium, potassium, iron, aluminum, manganese, silicon, etc. Then you can have sea salt. Again, you recall we were talking about the sea salt, but if we see in terms of composition, we know that the salt we eat also come from sea. So mostly it is sodium and chloride, but there is also sulfate, magnesium, calcium, potassium, etc. also within the sea salts. And then you have anthropogenic metals. So I was talking about industrial or regular emissions. So variety of combustions produce different anthropogenic metals in the atmosphere, like lead, zinc, chromium, copper, cadmium, nickel, vanadium, etc., etc., etc. Now, overall, what we see that there are thousands of chemical species present in the atmosphere as aerosols. Obviously, they are not uniform in time and space. What does that mean? That means in the morning, whatever composition you have, in the afternoon, it will be different. In the evening, it will be different. Night, it will be different. If you go from place to place, that means Ahmedabad is different. Delhi it is different. Nagpur different. Chennai different. Bombay different. So at different places you go, the composition will be different. Why? Because the sources are different. Everywhere, all sources are not same. So depending upon the sources, this composition will also be different. And when all these things are different, so they also have different physical or chemical or optical characteristics. In addition to all these particles go transformation process during the aging. So I told you that their lifetime is just about a week, but within this week, they will transform. Now, if you recall, transform is ant can become moon. Recall that? So if ant is becoming moon, that means there is multiple transformations are going on within the atmosphere. So what kind of transformation are those? Let us just discuss a bit. So transformation process we talk about. So by now we know that we have aerosols in the atmosphere, and this aerosol can be organic or sea salt or metal or dust or black carbon or anything like that. Then you have some humidity in the atmosphere. RH is relative humidity. Depending upon the high hygroscopicity of aerosol, some RH will condense on this aerosol, and this will have now liquid water content. LWC means liquid water content. Now you have water also on aerosol. Then these gases, VOCs, volatile organic compounds, NOx, ammonia, and all these gases, they can diffuse. All these gases can oxidize by a variety of oxidants like hydroxyl radical or hydrogen peroxide or ozone or nitride radical. Different oxidants are active during different times. So nighttime, nitride radical is more active, daytime, OH radical is more active, but by different oxidants. Now these gases get oxidized and form sulfate or nitrate or sulfate or brown carbon at the surface of existing aerosol. So now, as I was talking about the transformation process changing, and if you again recall, these are the process which are making ant into moon. So because of this, there is a change in characteristics like physical, chemical, optical, and isotopic characteristics. What does that mean? So there is a change in size. So you have some small size. Now you are coating on the surface, you are increasing the size, you change the surface properties, like for example, black carbon or dust, they are hydrophobic in nature. That means they don't like water. But if you have a coating of sulfate or nitrate at the surface, they become hydrophilic. So suddenly they start liking water. Optical properties. Earlier, black carbon is absorbing type, but if you have a coating of sulfate, this optical property will be different. Change in the bioavailability of nutrients. So when we say bioavailability, what does that mean? Say if you have some 100 gram of iron which you are putting in the ocean, but all 100 gram is not useful for the phytoplankton present in the ocean. Only soluble fraction is important for them. So if 1% is soluble, so out of 100, only 1 gram is going to them. But because of this process, if you decrease the aerosol pH, increase the solubility, so down from 100, instead of 1 gram, it may go 5 gram, 10 gram. That means 5 times or 10 times more soluble iron is going. And then that is how it can affect the surface ocean biogeochemistry, which I'll be talking a little later in the presentation. So overall, what we see that we all have different sources, different transformation processes, and they can change physical, chemical, and optical properties. Then aerosol, as I was telling that lifetime is just about to be, they get removed from the atmosphere. How do they get removed? They get removed by dry deposition, which happens around the year, and these processes include sedimentation, like simple gravity, diffusion from higher concentration to lower concentration, impaction. So while flowing, if it hits any surface, it gets attached there, or absorption. So many of you would have seen at home, is your home is say at 10th floor, 12th floor of a building, but still you see dust on different objects in your house. They are all aerosols, and for during following this process, they are getting deposited on those surfaces. In addition to dry deposition, there is a wet deposition, which is the major removal pathway, which is active during rain. So when rain is happening, whatever is present below the clouds, they all get removed from the atmosphere because of the rain get dissolve them and brought back to the surface. But if how something has been crossed over the clouds, that means it has reached to stratosphere, so then it is not coming down, and that is why lifetime in stratosphere is order of years. But if it is within lower troposphere, that means below clouds, it is about a week. Okay, moving further. So again, the question comes, so these aerosols are there, let them be there. If they are getting deposited in my home, I will dust it, I will clean it with the cloth. What is the big deal? Why should we worry about that? So what are the effects of atmospheric aerosols? So they affect in a wide variety of ways. So they affect our climate. How? So they affect radiation budget. What does that mean? That energy from the sun is coming in short wave radiation. From the earth, it is coming out in long wave and short wave both. And if they are balanced, everything is fine. But somehow, if you increase the incoming or decrease the outgoing, then it will warm. Same way, if you reduce the incoming and increase the outgoing, then it will cool the earth. So depending upon what is there in the atmosphere, it can affect the energy balance and then it can warm or cool the earth. Then aerosol also affects hydrological cycle. How? As a seed for cloud. There in the atmosphere, we have water vapor also in the atmosphere, but water vapor is not able to condense. But once they have aerosol, which are providing the surface, they condense at the surface of the aerosol and from cloud droplet. That cloud droplet may become rain and come back in the form of precipitation. But as I said, RH is getting attracted to the particles. But if the particle is hydrophobic, I was talking about black carbon and dust, then it will not allow water to come and sit on it. But if it is hydrophilic, like sulfate aerosol, nitrate aerosol, or water soluble organic aerosol, they love water. They will welcome water vapor to condense on. So depending upon what kind of aerosols we have, they can affect the precipitation, which we will talk till more in details in coming slides. So it can affect radiation budget and hydrological cycle, and that is how it is affecting our climate. Then it affects our air quality. If you are living in a big city and go at the terrace and see around, you see this kind of dirty atmosphere in the surrounding. These are all haze because of aerosols. This is the picture from satellite. If you, some of you can recognize, these are Himalayas, and this is Indo-Gangetic Plain, and this is Bay of Bengal. And this thick layer is because of aerosols. So aerosols are such high in concentration, you can see them from the satellite. So yeah, they are affecting air quality. Then they affect human health. How they affect, we will talking in details in the coming slides. And then they affect atmospheric chemistry. So the way, as I was telling you, that they welcome RH at surface, same way they provide the surface for different gaseous species and allow them to come at the surface and react and do the different kind of reactions. Many of you, if you are from chemistry background, you know that in order to make any reaction happen, you have to have molecules together. They should interact, and then only their product can form. And for that, aerosols provide the surface. And that is how it affects the atmospheric chemistry. And it also directly participates in the atmospheric chemistry, not only surface providing surface, but directly also it can affect the atmospheric chemistry. And then it affects our aquatic ecosystem. So now, if you recall, I was telling about the removal of aerosol via dry and wet deposition. So if those aerosols are getting deposited over ocean, so that is actually become the supply of nutrient to the remote ocean or lakes. So aerosols having all kind of nutrients like nitrogen, phosphorus, iron, etc., and they are putting the nutrients to the ocean or remote lakes via atmosphere, and that is how they affect the aquatic ecosystem. Again, this will be I will be talking a little more in details in the coming slides. And then it can also cause acid rain, depending upon again what kind of composition we have. If you have too much of sulfuric acid, nitric acid kind of compound, it may result in the acid rain. In India, we don't see too much acid rain because our soil is quite calcareous. Means it is you have too much calcium, magnesium, sodium carbonate, which can easily neutralize the acid. So that is why you don't get acid rain. But if you go to temperate regions, there are multiple places where acid rains are recorded, and they can affect in wide variety of ways, including from monuments to crops and all kind of things. And in any effect we talk about, the size and composition are the important factor. So for example, if somebody had talked to you about the optical properties, and then he or she would have talked to you about the size parameter. So depending upon the size, scattering efficiency will be different. So if the aerosol size is similar to the wavelength of the sunlight, for example, in the middle, that is green wavelength, so then this scattering will be maximum. Otherwise, it will be different. And composition, as I was telling you, if it is hydrophilic, it is different way it behaves. If it is hydrophilic, it behaves differently. Same way, it can absorb or scatter, so it behave differently. So size and composition both are important in assessing the effects. And then again, if you recall, I was talking about the transformation process, which again can affect the size and composition. So initially size or composition was different, but after transformation, the size and composition became different. So all these things are important when we are trying to study the effects of aerosol on our Earth system, whether it is climate or air quality or aquatic ecosystem. Then the question comes, so okay, aerosols are there in the atmosphere, but how do we measure them? What are the ways by which we can measure? So there are multiple ways, offline, online. I will tell you what does that mean. And this range from ground-based sensor, that means you can do the measurement at the ground level, at surface level, all the way to the polar and geostationary satellite. From satellite also you can make measurement. we'll be talking a little more in details now. So first, let us talk about the offline sampling. Offline sampling means you take a sampler. This is called high volume sampler, which has a flow rate of 1200 liter per minute. And this is the filter before you blank filter without aerosol, and this is with aerosol. That means after some 12 to 15 or 24 hours of sampling, this kind of aerosol you are collecting on this kind of filter. Then you have LVS, low volume sampler, which has a flow rate of 17 lpm, liter per minute. So LVS is about 70 liter per minute, HVS is 1200 liter per minute. So we are using smaller filter here. Again, this you can see this white portion is the blank filter, and these are collected aerosol in different environments. So you can see different colors. In addition to this, they both are filtering the aerosol through the filter. This is how you are collecting. You have impactor, which is not by filtration but it is by impaction. So here you pull the aerosol with a certain flow rate. So bigger particle hit first, smaller particle will pass through and hit second plate. Further smaller particle can again pass through and hit the other plate, and that is how you get the aerosol on different plates. And this is how they look like. So this is bigger particle, then smaller, then further smaller, and further smaller particles. And usually the cascade impactor has a flow rate of 30 liter per minute. And now, how do you decide the sampling? Samples are all, when we're talking about the outdoor air, so they are collected outdoor, that usually at the terrace of a building or any sites above the ground level with the free flow from all the sites. Duration of sampling depend upon where you are doing the sampling, whether it is polluted or pristine site. For example, if you are doing sampling polluted city like Delhi, then you can collect few hour sample and you will have sufficient sample like this. But if you are at a place like Antarctica or Arctic or Mount Everest or any very clean place, then few hours will not be sufficient to collect sufficient aerosol. Then you have to run for 2-3 days or even more number of days to have sufficient amount at the filter so that you can bring it back and do the analysis in the lab. And what kind of analysis we do? There can be wide variety of things like water solving inorganic species. That includes sulfate, nitrate, ammonium, sodium, calcium, magnesium, etc., all ions. Then you can measure trace metals like iron, aluminum, lead, zinc, etc., etc. You can have water soluble organic OC means organic carbon, and water soluble TN means total nitrogen. You can have bulk organic and elemental carbon, which is called OC and DC. You can have organic speciation. When we say speciation, it means now you are trying to find out whether it is PHS or aliphatic or alcohol or ketone or ester or what. So then it is organic speciation. Then you can have brown carbon. This is a type of organic carbon which are absorbing in nature. Then you can do the speciation of brown carbon. You can measure oxidative potential. Little bit we will talking about in the coming slides. You can measure variety of stable or radioisotopes. They are for very specific purposes, which I will not be discussing today, maybe sometime later. And then very new things people can collecting aerosol for several hours or several days. Here you are not collecting for several hours or several days. It is every minute. Every minute you are getting data. So you have instrument like environmental beta attenuation monitor, which is called EBAM for PM mass concentration. And now these are very popular thing, low cost sensor, again for mass concentration. And now if we, in addition to mass, if you're also interested in getting the size of the particle, then we use scattering probability particle sizer, which is called SMPS. Then if you want to do chemical speciation, there are instruments like aerosol mass spectrometer, which measure non-refractory organic and inorganic species. Non-refractory means up to certain temperature, means say up to 600 centigrade, whatever can volatilize, it can measure that. If you have volatilization after that, that means dust particle and all, it cannot measure, but other compound, this AMS can measure. And then you have this X ambient continuous metal monitor, which is called ZACT, and this for metals in the atmosphere. You have aethalometer for black carbon measurement, and these are all at down level. And this, if we talk about, this is from satellite, remote sensing. And you have very multiple passive or active remote sensing sensors at the satellite, which are doing the measurement for aerosols. So in short, in as a summary, if we see, so when we talk about aerosol measurements via multiple ways, offline or online, so you can have in situ or ground-based measurements like filtering through filtration, high volume, low volume samplers, through impactor, cascade impactor, and then do gravimetric analysis and do variety of ions and metals and carbon, etc., in these filters. You can have online measurement by SMPS. APS is aerodynamic particle sizer for particle size distribution. OPC is optical particle counter, particle number in percentage for particle number in size concentration. Nephelometer for scattering coefficient. Athlometer for black carbon. AMS for real-time chemical specification of non-refractory mass. LiDAR for aerosol backscatter and vertical profiles. And you can do the measurement at surface layer, in boundary layer. You can use drone or balloon, and you can do vertically and from satellite. As I said, variety of measurements are already available. So you can have polar satellites or you can geostatic satellites. Variety of satellites are listed here. This is our own satellite InSat 3D. So overall, these are the instruments and these are the application. So for aerosol measurements. Now let us move further. So now we talked about aerosols. What are aerosols? Size, composition, what kind of species, etc. Now the question comes: why one should study the chemistry of atmospheric aerosol, which was the topic of my talk. Now the answer is to identify sources and processes affecting aerosol abundances, and also to understand and assess their effects ranging from air quality to climate change and planning the mitigation strategies. I will tell you a few examples in detail. I few things which I am not going to tell, let me tell here only. So to identify sources, for example, if you are not doing chemistry, if you are just doing physical or optical properties, you will say, okay, this some particle is there of this size. But what is that? You don't know. But if you are measuring the chemical composition, you can say, no, no, it is sea salt. No, no, it is ammonium sulfate, or it is dust, or it is metal, or black carbon. So once you identify the particle chemically, then you can say, then you can think of the sources. If it is sea salt, that means it is coming from sea spray. If it is dust, you can say it is coming from windblown dust. If it is some kind of metals which is from certain industries, you can say that industry has emitted the particles which you are getting. So in any kind of mitigations, if you are planning, you should know the sources. So that is why it is important. Processes, again, if you got transformation processes which affect many things about aerosol, which help aerosol or which help ant to become known in the atmosphere. So you should understand the process. And then another effect, which I'll be telling you more in details now. So now let's talk about how composition, aerosol chemical composition and earth radiation methods are connected. Just a second. So now if you notice, I am telling a little more in detail whatever I showed you earlier. We have sun, we have earth, radiation coming in, going out. Things are balanced, everything is fine. But now you have aerosol in the atmosphere. What they can do, they can reflect the incoming radiation, and reflecting type of aerosols are sulfate, nitrate, and organics. They can absorb and irradiate. What kind of aerosols are they? Black carbon, brown carbon, dust kind of aerosols. They can form clouds and then reflect, which is this is direct effect. This is indirect effect. We know that they act as a cloud condensation in play. Hydrophilic species are more effective CCN. Hydrophobic species behave oppositely. I gave you the example earlier. So this process affect the cloud lifetime, precipitation, and different type of aerosol have different effect on earth radiative forcing, mostly negative. Negative forcing means it is cooling the earth, but overall means aerosol cools earth. That's correct, but they have many other adverse effects. Now aerosols and rain, if we talk about, so again this is indirect effect which we discussed in earlier slides. Now see, this is clean cloud, this is polluted cloud. What does that mean? So you have some amount of water vapor available in both the cases. And you are putting number of, if you again recall, I told you that aerosols are seeds for cloud. Now, but if you are putting too many seeds, so what will happen? That the amount of water will be distributed over more number of seeds. Then the rain droplet which you are forming will become smaller. So more number of smaller cloud droplets are formed, less number of ice crystals are formed. That will cause the less precipitation. You will have cloud in the atmosphere, but it will not precipitate, and there will be more absorption. This will increase the cloud albedo. Cloud albedo means reflectivity. If you have more cloud for longer time, they will reflect more. It also increases the lifetime of the cloud. It will not precipitate. It will just remain in the atmosphere. And there will be increased evaporation. If you have absorption, the cloud droplets can evaporate. Unlike if you have a clean cloud, less number of seeds, you are making more number of bigger size cloud droplet and ice crystal, which reduce cloud albedo. There will be more precipitation and less cloud time. So overall, this is the process which has shown that how this cloud macrophysical process behave. So we have different water vapor molecule condensing on aerosol, and then they coalesce together from rain droplets. Again, they coalesce together for the bigger rain droplet, and it fall that at the ground. Now the question comes: how aerosol affect our health? This is very important part. Everybody is concerned. We are all concerned. And for many years, it is understood that aerosols affect our cardiovascular system, which includes coronary artery diseases, heart attacks, strokes, blood clots. It also affects our respiratory system. It includes chronic obstructive pulmonary diseases, asthma, lung cancer kind of diseases. This is known for a longer time, for multiple decades. But there are growing evidences that the effect of air pollution are much beyond the respiratory diseases only. What are those effects? The aerosol can affect our brain. It can cause Alzheimer disease and cognitive decline. You probably know Alzheimer means you are forgetting everything. You don't remember anything. Cognitive decline means your reasoning power is decreasing. It can affect your nervous system, which called Parkinson disease. You might have seen, so some people have this shaking hand. It's a part of Parkinson disease. You can have other neurodevelopmental disorders. They can affect renal system and they can cause chronic kidney diseases. They can affect endocrine system, called obesity. It can cause obesity or diabetes. It may affect reproductive system, which can diminish the fertility. It can cause premature births. It can cause low birth weight. Even people have seen that aerosol particle affect embryo. Soot particles, which are actually black carbon, are shown to reach the lungs and brains of infants even before they are born. So now you see how deep aerosol can reach and what kind of effect they are causing on us. Some are known, many are unknown. And these effects can be acute or chronic. What is the reference? Acute means immediate effect. Suppose means there is a huge pollution and some people are dying. So that is called acute effect. But chronic effect is like a slow poison, and which we are facing every day. You are passing by the huge traffic. You are inhaling the all kind of pollutants, which is not affecting you immediately, but slowly they are affecting your health. I will tell little more detail about this. So okay, let us discuss that. So how deep this aerosol can reach in human body? Now, if you recall, I told you that aerosol has a wide variety of size. You remember coin to crater. So these small are coin and this bigger are crater kind of. But your nose was designed by the Almighty in such a way that all the particles bigger than 10 micron in size, they can't cross nose. They are trapped in the nose itself. Now you understand that why the PM10 means you can have PM8 or PM12 or 15, etc., etc. Not. We said PM10. So this was the reason why we are talking about PM10. PM10 can reach from this region, trachea region. Then if you have further smaller particles, which is PM2.5, again recall, I told you about what is PM2.5. Then they can go deeper in lungs, up to here. Further small particle, PM1, again recall PM1, they can reach deep inside the lungs, which is called alveoli region, here. And then again, if you recall PM0.1, that is PM less than 100 nanometer, ultrafine particles. They have a capability to pass through the macrophage and get into the bloodstream. And we all understand that if something is reaching to our blood, that means it can reach to any part of our body. And if it can reach any part of our body, it can affect the way we discussed in the previous slide. But this is also true that particles go in with the inhalation and comes out also with when we exhale. But a fraction of particle get deposited to the epithelial cell. What are epithelial cells? If you can see inside our lungs, so whatever cells you see in the surrounding, they are called epithelial cells. So how do they affect actually? There are multiple mechanisms, and one of the mechanisms which are quite accepted is through Ross imbalance. What is that? Ross means reactive oxygen species. You know, in our body, we have antioxidants like glutathione or ascorbic acid. We have oxidants also in our body like hydroxyl radical, superoxide ion, hydrogen peroxide. So if there is anything or imbalance favoring oxidants or disfavoring antioxidants, that leads to damage of variety of damages, Ross imbalance, which causes oxidative stress, inflammation, and cell death, and which results in variety of diseases, which we were discussing in the previous slide. And again, if you recall this word, oxidative potential, so capacity of particles or aerosol to generate Ross and or deplete antioxidant is called the oxidative potential. So within aerosol, if they have high oxidative potential, they will cause more Ross imbalance. If it has less oxidative potential, they will cause less Ross imbalance. Usually, the natural aerosols are having less oxidative potential, whereas anthropogenic aerosols are having much more oxidative potential. That means anthropogenic aerosols are very toxic compared to natural aerosols. Okay, then I was talking to you in the beginning, if you know, recall the nutrient supply. So we have already discussed, we have a variety of sources from different processes. These aerosols, through atmospheric transport, these aerosols are going from continent to remote regions. Again, you recall, they get removed over the land or ocean via wet or dry deposition. They get removed from the atmosphere. It can be rain, cloud, fog, or under gravity or turbulence settling. Again, if you recall, atmospheric processing or transformations can change the bioavailability of nutrients. I gave you one example. Now, suppose this is the dust, and this dust contains 100 gram of iron. That whole iron is not bioavailable. Only a small fraction. But bioavailable is whatever soluble fraction is there, that is bioavailable. But because of this transformation process, this bioavailable fraction can increase, and then it can affect in a variety of ways. So what are the nutrients it can have? It can have macronutrients like nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, etc., which are essential for primary productions. These nutrients and trace elements are delivered by aerosols. They can be trace metals like iron, manganese, zinc, copper, cobalt, nickel. They are required for cofactors for enzymatic and metabolic processes. You can have micronutrients like silicon, molybdenum, boron, vanadium, which supports specific biological functions. We can have variety of organic matter, which can be dissolved or particulate organic matter like amino acids and lipids. They all affect the act as nutrient. And their effects, if we talk about, they enhance the primary productivity. Primary productivity means these are the kind of food available for fishes. If you increase, that means you can increase the number of fishes. And if you are changing, and this also affect the carbon cycle. I will tell it in detail. So it can enhance the primary production by this kind of nutrients. It can alter the community structure, the shift in phytoplankton species composition and diversity. There can be changes in the nutrient cycle like nitrogen, phosphorus, silicon, and trace metal cycling in the surface ocean, which can increase regeneration or increase demineralization, influence the carbon cycle. So during the process of phytoplankton, it needs carbon dioxide, which it takes from the atmosphere. So in a way, phytoplankton formation process is removing that CO2 from the atmosphere. which is, means, you may be knowing that ocean is a major sink for carbon dioxide from the atmosphere. When it is removed in the some form, it can go down to the deep ocean, and that is removed for many long time, millions of years. Again, depending upon what kind of aerosols you have, it can affect the surface pH and ocean acidification, deposition of nitrogen and sulfur compounds, can modify pH, and that can affect the buffering capacity. All these processes can affect the ecosystem and fishery impacts, changes in food web dynamics and productivity, and ecosystem balance. So overall, if we talk about aerosol linked distant continents with remote aquatic ecosystem influence global biological cycle and climate. So atmospheric aerosols are a vital natural pathway for delivering essential nutrient and trace element to the remote ocean and lakes, which profoundly shape surface biodiversity and ecosystem health. Now, if I summarize everything together, so what does that mean? Aerosol affect our environment in many ways, from air quality and human health to climate change and aquatic biodiversity. We have seen the example of almost all of them. Aerosol aging, which is transformation, is the in the atmosphere causes numerous transformation in the physical, chemical, and optical properties, which in turn can modify the assessment of aerosol effects. I told you when we were talking about the transformation process. Then, in any effect we are talking about, studying chemistry of atmospheric aerosol is inevitable to understand any effect of aerosol. But overall, only chemistry also will not help. So overall, when we say comprehensive studies on aerosol physical, chemical, and optical characteristics with a good temporal and spatial resolutions are important to effectively understand the impacts of ambient aerosols on our environment and plan appropriate mitigation strategies. With this, I wish to thank you all. And if you have any questions, I'll be very happy to answer.